Now that we have already learned all the basic theories and concepts for electric circuits, we are now going to do practical work. So in this video, I'm going to teach you how to use the ammeter, voltmeter, and how to connect the different components of a circuit in series and parallel circuits. Okay, so the first device that we are going to talk about is the ammeter. So this is the ammeter that we have in the laboratory. What's the function of the ammeter again? An ammeter measures the electric current flowing in a circuit, or it can also measure the current flowing through a component in a circuit. Okay, so this is the available ammeter that we have in the laboratory. These red terminals are the positive terminals of the ammeter, and this black one is the negative terminal of the ammeter. Okay, and why do we have two positive terminals? These two positive terminals, this one on the left can measure up to 500 milliamperes of electric current, and this one here, it's a little shiny, we cannot see. This can measure up to 5 amperes of electric current. So it will depend. If you see that the current is just small, you just use 500 milliamperes. Okay, so that you can clearly see how much it is. Because sometimes you connect it here in 5A and then you will see the needle only up to here or here in the middle, and you cannot really read it properly. So you put it back to 500 milliamperes. Now, if you're connected to this terminal, you will read these numbers as 0, 100, 200, 300, 400, and 500. But if the positive terminal is connected on this side, in the 5 amp side, you will read this as 0, 1, 2, 3, 4, and 5. Okay, and then always remember positive terminal of the ammeter should be connected to the positive of the battery. Negative terminal of the ammeter should be connected to the negative terminal of the battery. Okay, so how do we connect an ammeter in a circuit if we want to measure electric current? For example, this is our circuit diagram. We have one lamp connected by wires to a battery. This is our source. Electric current, ammeter measures electric current flowing through a circuit or flowing through a component. So for example, we want to know the current flowing here. Since it's only one lamp, whatever the electric current is in the circuit, it's also the electric current that flows through this lamp. So how do we measure that? Since we are measuring electric current, we need to allow electric current to flow through the ammeter. So for example, we can break the circuit here, either here or here. When we break this circuit here, we will insert the ammeter here, just like this one. Oh, by the way, this circuit diagram is this in real life. Okay, one lamp connected to a battery by two wires. You may not see it, it's very small here, but it is lighted up. Okay, so we break the circuit here and then connect the ammeter here. So remember, we need to connect the ammeter in series to the component. Why should it be connected in series? To allow current to flow through the ammeter because we want to measure electric current. Okay, so in practical work, this is how it should look like. So from this diagram, I broke the circuit here. So I just unclipped this one here and then connected the ammeter here. Okay, so this negative terminal connected to the negative of battery. This positive is connected to the positive of the battery. You don't need to, it doesn't mean that this positive should be connected here. It's just positive on the positive side also. So let's look at the reading. Okay, so we are connected in the 500 milliampere terminal. So we should read this as, so this is 0, 100. So this will be 160 milliamperes. Okay, so that's how we read it. Sometimes there are instances when this happens. What do you do when this happens? Some students panic when they see this. It only means that you have reversed the polarity of the connections. You just need to switch these two and it will go back to its original reading. Okay? To the correct reading, I mean. Next, we have a voltmeter. A voltmeter is used to measure voltage across a component, okay? Or the potential difference across a component. Just like in our ammeter, we also have two positive terminals and one negative terminal. This one can measure up to 5 volts. So if your wire is connected here, you will read down here below. 1, 2, 3, 4, 5. But if you're connected here in the 15 volts, you will read this, the one on top, 3, 6, 9, 12, 15. Okay, now how do we connect a voltmeter so that it can measure potential difference across a component? An ammeter should be connected in series. A voltmeter should be connected this way. For example, this is a lamp. We want to know the voltage across the lamp or across this battery. Since this is potential difference, remember the potential difference here in the positive is higher, the potential here in the positive side is higher than the potential here in the negative side. So there's potential difference. So if we're talking about potential difference, a voltmeter should be connected in parallel. One side here, one terminal here, the other terminal here. Why? Because we want to know the potential difference between these 2 points. Same thing here as this lamp. If we want to know the voltage of this lamp, potential difference from here and then here. Remember, this is from positive, so this is area of high potential, area of low potential. So you want to know the difference, we just connect it parallel. Okay, just like this way, if we want to know the voltage across this lamp. Okay, so this is how we should connect it. This was our original one, a battery connected to one lamp. If we want to know the voltage across the battery, this one actually, voltmeter is actually easier to use than an ammeter because you do not need to break the circuit for just to use the voltmeter. Okay, so we want to know the voltage across this battery, just connect it here, positive to positive, negative to negative. Okay, so here's the reading. We are connected here in the 5 volts area. So we read this as 1, 2, 3, 4. If you see something like this, it's in between 3 and 4. You just get the lower one. So we read this as 1.3 volts. Do not assume that this is 0.05. You cannot say 1.35 because we're not sure about the divisions between these two. Okay, so you just get the lower one, 1.3 volts. Okay, again, if this happens, do not panic. It only means you have reversed the polarities. Just switch them. Okay, so now it's normal. Oh, and by the way, as you can see, since this voltmeter is used to see the potential difference across a component, if you have a battery, since this is the source of potential difference, you do not need a complete circuit just to find out the voltage of this battery. Because this battery has potential difference already, you just connect the voltmeter directly. Okay, so that's how easy it is to use a voltmeter. Now let's talk about two types of circuits. We have series circuit and parallel circuit. What's the difference? In series circuit, there's only one path for current to flow. Just like, for example, this one, we have two lamps. We connected them in series. This means there's only one path for electric current to flow, nowhere else. It's just this one. Okay, and then how does it look like in real life? This one, a battery, two lamps connected in series, meaning there's only one path for electric current to flow. What is this here? Okay, parallel circuit, there's more than one path for electric current to flow. For example, we have two lamps. We connected them in parallel. Why? Because there are more than one path for electric current to flow. Where are those paths? This is one path, and this is the second path, parallel circuit. Okay? This is how it looks like if you do this in the laboratory. You may not see it, but both lamps are lighting up. Okay, so this is one path, and here is the other path. So what if we want to measure the electric current flowing through this lamp? We just break it here, break the circuit here, and connect the ammeter here, this way. And this is how it will look like. I broke the circuit here and connected the ammeter. Okay, if it's a voltmeter, very easy to use. You just clamp it across a component, across a lamp, across a battery. Here, what if we want to know the current flowing through this lamp? We break this circuit and connect this ammeter here. Why? Because whatever current flows here, it's also the same current that flows through this lamp. Okay, now what about resistance? We've been talking about the voltmeter, a device to measure voltage, ammeter, a device to measure electric current. Is there a device to measure resistance? There's no device to measure resistance. So how can we find out the resistance of a component in a circuit? For example, we want to know the resistance of the lamp in the circuit. What do we do? So what we do is just find the electric current flowing through the lamp, and then also find the voltage across the lamp. Then using Ohm's law, rearranging it so that you'll have formula for resistance, it will be voltage divided by electric current. Voltage across the component, electric current flowing through the component. Okay, so remember this resistance. Every component in the circuit has its own resistance. Now, let me just discuss these two types of graphs. If we have this current versus voltage graph, why is the voltage here in the x-axis? Because this is our independent variable. This is what we change. So what can we see about the relationship between voltage and current? As you can see, as voltage increases, current also increases. Okay, and from this graph, since this graph is a straight line and it's passing through the origin, we can say that voltage is directly proportional to current, or current is directly proportional to voltage. Why? Again, because the graph is a straight line and it starts through the origin, 0, 0. Now this graph is characteristic of an ohmic resistor. Okay, so ohmic resistors, or our fixed resistors, current is proportional to voltage. However, there are resistors wherein current is not proportional to voltage. For example, a light bulb. Okay, this is the current versus voltage graph for a lamp. What can you see? What can we say? As the voltage increases, current also increases. However, at a certain point, they are no longer proportional. What happens here? It's because as potential difference increases, current increases also. The filament of the lamp gets hotter. And for this specific lamp, or for lamps with filaments, as they get hotter, resistance increases. So the current that will flow through it will also decrease. Did I say it correctly? As the temperature goes higher. Why is the temperature goes higher? Because you've been using the lamp for a long time. Temperature increases, resistance increases, and so the electric current decreases. So this is for a lamp. So a lamp is not an ohmic resistor. What's an example of an ohmic resistor? Those are the resistors which have fixed value of resistance, the one with color bands. Okay, so that's it. After this video, you should perform the laboratory work, and I will give you the laboratory worksheets.